The huge explosion. A starting point. To see the value in what could have existed before the huge explosion, we should initially comprehend what the huge explosion itself was. The huge explosion, as depicted by science, alludes to the second when the universe turned out to be extraordinarily hot and thick, extending quickly to make way for the development of all matter, energy, and powers. When we take a gander at the night sky, we see proof of this hot start, with systems fanning out from a solitary point. But for what reason did this occur, and was there a period before this thick, hot beginning? Astronomical expansion and the multiverse. As per the hypothesis of vast expansion, there for sure was a previously, and it was a long way from vacant or calm. Infinite expansion proposes that before the huge explosion, the universe was in a state that was cold, unfilled, and free, an immense vacuum, yet not totally void. This vacuum contained colossal energy that energized the fast extension of room itself. This extension, known as inflation, happened so quickly that it set the establishment for all that we know. In a small portion of a second, space extended at staggering rates prior to dialing back, changing over energy into particles and powers, making the enormous detonation. What was the idea of this energy? For what reason did it abruptly make the universe, and for what reason did it stop? Researchers propose that this limitless extension made patches of the universe, each going through its own huge explosion. Envision a texture extending endlessly, with minuscule air pockets shaping, each air pocket addressing a universe, including our own. This thought, known as the inflationary multiverse, proposes there might be incalculable huge explosions and an endless number of universes. Our own is only one among numerous. This brain-bowing idea challenges how we might interpret the actual universe and brings up the issue: what else is out there? The idea of nothingness. The idea of nothingness before the enormous detonation is hypothetical, not outright. Regardless of whether we strip away all energy, particles, and radiation, the universe wouldn't be genuinely vacant. Our universe is loaded up with dim matter, dim energy, quantum fields, and powers that are complicatedly entwined. Even in its emptiest state, space would in any case make new types of energy. This acknowledgement puzzles researchers, as it recommends that genuine nothingness might be incomprehensible inside our comprehension. Space itself has properties, decides, and constants that keep it from being totally void. For instance, zero-point energy alludes to the least energy condition of quantum fields. In this state, particles can in any case show up and evaporate, making transient changes even in seemingly vacant space. Quantum fields and virtual particles. Quantum field hypothesis offers another viewpoint. It proposes the universe isn't just matter drifting in space, but a complicated organization of energy fields that fill the universe. These fields, like imperceptible seas, communicate to make all that we notice. Even in their least energy state, known as the vacuum state, these fields stay dynamic, generating particles that show up and vanish quickly, virtual particles. This peculiarity challenges the possibility of a vacant void. Even in a universe deprived of all matter and energy, these fields would endure, guaranteeing that outright nothingness doesn't exist. Dim energy and the multiverse. Dim energy, a strange power driving the sped-up development of our universe, might have played a part before the huge explosion. A few hypotheses recommend that dim energy, in a much stronger state, might have controlled the inflationary stage, causing fast extension. Might dim energy at some point have made the circumstances for the introduction of our universe? Could it be the quiet draftsman of expansion, or even the genuine start of everything? Provided that this is true, this power could hold the key to understanding the multiverse itself. Cyclic cosmology and everlasting expansion. Another hypothesis, cyclic cosmology, offers an option in contrast to the huge explosion as a conclusive starting point. This speculation suggests that the universe goes through gigantic patterns of birth, passing, and restoration. Timeless expansion, a connected thought, proposes that inflation never genuinely ends but keeps on generating new universes endlessly. Envision each huge explosion as a flash lighting another universe while expansion occurs in different districts, creating incalculable extra universes. This ceaseless cycle prompts the possibility of a fractal universe, where each new universe might generate its own huge explosion. The chance of an endless multiverse challenges the manner in which we decipher reality. There might be no genuine beginning or end, but rather an everlasting pattern of universe development. The idea of a fractal universe. The idea of a fractal universe proposes a structure where each new universe resembles a branch from a tree, endlessly bringing forth new universes. Each huge explosion might be viewed as 1 second in a stupendous and continuous cosmic cycle. Assuming this is valid, it reshapes how we might interpret presence. Rather than a single beginning, presence becomes a limitless movement of universes, each with its own laws of physical science, aspects, and timelines. This hypothesis likewise presents a significant philosophical inquiry. Assuming that our universe is one among endless others, does it hold any exceptional significance? Or are we part of a perpetual sequence, no pretty much significant than the universes that preceded or those that will follow? Past time, quantum gravity and circle cosmology. Delving further into the universe's origins, a few physicists turn to hypotheses of quantum gravity, which attempt to combine general relativity and quantum mechanics. One such hypothesis, loop quantum cosmology, proposes that the huge explosion was not the beginning but a transition. As indicated by this thought, the universe might have existed in a past stage, contracting to an unimaginably dense point before expanding again. This huge bounce replaces the idea of a flat-out beginning with a recurring process. If valid, it implies a universe that wavers between periods of extension and contraction, endlessly renewing itself. Hints from the cosmic microwave background, CMB. Evidence supporting a portion of these hypotheses could already exist in the cosmic microwave background, CMB, the faint glow left over from the huge explosion. Researchers concentrate on designs in the CMB to look for irregularities that could indicate a universe before our own. For instance, a few specialists estimate that specific features in the CMB might be scars from events predating the huge explosion. These patterns, if confirmed, could provide direct evidence of a past cosmic cycle or interactions between universes in a multiverse. Challenges to understanding before the huge explosion. Despite these captivating hypotheses, the subject of what existed before the huge explosion remains one of science's most challenging mysteries. The actual concept of before is complicated, as time itself began with a huge explosion. Without time, our regular understanding of causality breaks down, making it hard to define what before truly means. A few researchers argue that the inquiry is inherently unanswerable, as our current physics can't probe beyond the singularity of the huge explosion. Others believe that new breakthroughs in quantum mechanics, string theory, or other emerging fields could eventually provide answers. Philosophical and spiritual implications. The quest for what preceded the huge explosion isn't simply a scientific endeavor. It also addresses significant philosophical and spiritual questions. Many traditions, both ancient and modern, have wrestled with the idea of a universe without a beginning or end. For some, the concept of an eternal multiverse aligns with spiritual ideas of boundless creation. For others, the idea of a recurrent universe resonates with philosophies of renewal and resurrection. No matter what one's perspective, these hypotheses challenge us to reconsider our place in the universe and our understanding of existence itself. The future of exploration. As technology advances, our ability to test the mysteries of the universe will continue to grow. New telescopes, particle accelerators, and theoretical frameworks might help us uncover clues about the universe's earliest moments or even its predecessors. In the meantime, the question of what existed before the huge explosion remains one of the greatest mysteries in science. It serves as a reminder of the limits of our knowledge, yet also inspires us to continue pushing the boundaries of discovery. Perhaps the ultimate answer lies not in finding a definitive conclusion, but in the pursuit itself, challenging the very essence of what we know and what we might one day understand.